All right, here I'm going to talk you through a couple different graphs. I figured we could spend a little bit of time here just looking at these graphs I created. So, first things first, make sure that we know we're looking at a position time graph. Our position units are going to be in meters. Our time is going to be in seconds. So on my y-axis, I have different positions. This object is traveling. It's a straight line on a position time graph, so I know it's traveling at a constant velocity. The velocity I can determine as the slope. It travels 6 meters in 1 second. So the slope is 6 meters per second is the speed. So in this case here, we're really looking at the slope here is going to be the rise over run, which is, we can calculate for any of these, right? I can just find the slope for 4 seconds, traveled 24 meters. So 24 meters, 4 seconds. All of these will get to the same answer of the slope being 6 meters per second. So slope matters here. In a straight line, constant speed. So let's look at a different type of graph. Let's look at a graph that is showing accelerated motion. Then notice the slope is changing. The slope is going from this gentle slope here to a steeper slope and just getting, it's increasing here. So as my slope is increasing, so goes my velocity. So a curvature to it is telling me that it's changing. If I had a different graph that had a curvature that was starting off steeper and then gradually kind of flatlined here, we would say, well, at some point right here when it stopped having slope, we would simply say that it stopped moving. It stopped its motion altogether. So here you can see a steeper slope, a gentler slope, and then no slope. So curved graph, curvature tells me that something's happening. We would say the speed is changing, or in this case the velocity is changing. So let's get a little bit more complex here. Let's see if we can do this one. So here I have segments A, B, C, D, and E. So I'm going to ask you a couple different questions and I'll go through solving them. So I'm going to ask you to say, well, what is the speed for segment A? So speed for segment A. Let's see. Position time graph, meters per second are my units. It traveled 20 meters, right? So my speed here for sub A, speed of A, 20 meters in, let's see here, 1 second. 1 second for a speed at position A of 20 meters per second. And for segment B, let's see, B traveled from this location to this location. It traveled 10 meters in 1 second. So the speed of B is going to be 10 meters per second, right? 10 meters, 1 second. C, it's going to have a speed of 0 meters per second. Notice here for segment D, traveled 10 meters in 1 second. So the slope of D is also going to be 10 meters per second. And last but not least, the location E, the slope of this, notice it's a negative slope. Well, we've defined our coordinate plane system as we've said, up is positive, right is positive, down is negative, and left is negative. If I'm traveling from my origin here, this is 0. If I'm traveling away from it, we would simply call that a positive slope. That these all have this implicit positive value to them. However, if I'm moving from this location here, we're really looking at the displacement. It's actually traveling back towards the 0 point. We would call that a negative slope. So if I solve for the speed of E, it traveled from 40 to 0. So if I'm finding the slope here, and we haven't done many problems like this, but here's what it's saying. It's saying that the position of y2 minus y1 is going to equal the x2 minus x1. In other words, y2, it ended up at 0. So I could solve this as 0 minus 40, right, meters, divided by, I end up at 5 second mark from 4, so it would be 5 minus 4. So 40 meters, negative 40 meters over 1 second tells me that the slope is the velocity of negative 40 meters per second. So my velocity here is negative 40 meters per second. It's simply just a directional element. We've defined these pluses and minuses, right? These are directional. So therefore, we're looking at vector quantities. These are velocities we're solving for. And as a result here, I want to do something, we haven't gotten into this very much, but I want to make sure you understand. The total distance traveled here from this graph, traveled from 0 to 40 meters, and then from 40 back to 0. The distance traveled was a total of 80 meters. However, the net displacement is 0 meters. And then last but never least, you can pause and rewind this, but let's get into this one. And I'm just going to talk you through this. Notice location A, or segment A, curvature, slope is increasing. We would say that the velocity is increasing here. Curved slope, curved upwards, slope is increasing. B, the object is stopped. C, the object traveled from the 15 meter mark, right, at this location here. It traveled up to the 40 meter mark, so it traveled 25 meters in 2 seconds. So I could find the velocity sub C. D is going to have a negative velocity, and E is going to have a negative velocity. They have negative slopes. So all things considered, make sure you are able to, I'm not going to ask you to solve for, I guess I could say what's the average speed for segment A, but I'm not going to, anything more than, you'll have to just be able to interpret this. You could say that the average speed would be 15 meters divided by 4 seconds. So you could find that. But this is a curvature. We're showing that it's speeding up. Slope is increasing, therefore, so is the velocity. You will need to make sure you know how to solve for these negative velocities. It's still the same thing. Velocity is still displacement divided by time. However, we can have a negative displacement if it's traveling back towards what we've defined here as our origin, our 0. And last but not least, I'm going to end on this one. The total distance traveled and the displacement. Remember, distance is a scalar quantity, displacement is a vector quantity. It traveled from 0, it went up to 40 meters, and it came back, it ended 5 meters away. So it went, let's see, 40 meters away, and then 35 meters back for a total of 75 meters. However, the net displacement would be 5 meters. It ended 5 meters away from the origin or the 0 point. There you have it.